All right, good afternoon, good evening to everyone again today, and thank you for joining this webinar. So to get started, the webinar today will cover the best practice data capture with ZEB Revo, RT, and ZEB Horizon. This session will be useful for anyone who is new to GeoSLAM or anyone who needs to refresh best practices or have a challenging project ahead. My name is Ivana Lubova. I work in GeoSLAM as application engineer, and I'm your today's presenter. During the webinar, you will be muted, so if you have any questions, please type them in the Q&A panel, and I will try to answer as many as I can at the end of the session. If you have any follow-up questions, they can be sent to info@geoslam.com, and the recording will be emailed to all attendees, and we will also keep them updated on GeoSLAM Academy, where you can find a variety of materials. So who is GeoSLAM? GeoSLAM was the first supplier of handheld products for spatial data capture. Our innovation is driven by diversity of our customers and markets they work in. This means that our technology can be used in all environments, whether it's indoor, outdoors, or any areas that are difficult to access and need to be scanned quickly. And in turn, we actively see customers that are looking to disrupt their industry by using our 3D capture technology. And where can you find us? The headquarters of GeoSLAM is in Nottingham in the UK, with the picture on the top. We have presence in 53 countries, making us able to support the customers all around the world. We are selling via dealer channel and have over 80 authorized GeoSLAM dealers as well. This is the outline for today's topics. I will start with the SLAM and in principle how it works, and get into individual system specifications, and so you can get an idea which system is the best for different projects. I will touch on the best capture practices in different environments, capturing with different cameras, as we have a range of them available for different systems, Horizon UAV best practices, georeferencing as the post-processing part of the data capture, and then questions and answers at the end. So SLAM technology, most of you must be familiar with simultaneous localization and mapping already. In each of our ZEB system, we use CT SLAM, we collect laser data measurements, and also inertial measurement or IMU unit information. Whether you have real-time system, Revo, or Horizon, SLAM algorithm does 3D feature recognition and performs scan-to-scan registration based on those features. And the process result is a registered point cloud. It doesn't require GPS or being static during the capture. To expand a little bit more on SLAM, when we turn the system on, let's say facing some static features like chairs or tables in the room, SLAM algorithm will extract those features by placing surface elements around them. Features that work well for processing have some unique geometry or at least 1 meter in size. So chair or tables in the room will work well. In the outdoor environment, trees, street sign, parked cars are also good examples of the features. However, repetitive features like brick wall, where each brick looks the same, would be a challenging part for SLAM to create trajectories you're walking through. if it cannot find any difference between those features. Okay, so let's say that you started the system on the table, slowly picked it and moved with the scanner to a new location. And from this new location, you can see the same features as you can see on the top right, image number 3. And again, SLAM algorithm will create the surface elements around those features. It will recognize they are the same. This means as a result, those features, the surface elements will be matched. Picture number 4. But also the result of this matching is that your position or trajectory will be also updated. So that's why it's simultaneous localization and mapping. And this process continues every second. For the successful data capture, the system needs to start close to some features, it needs to have those features throughout the capture, and finish at the same start location facing the same objects again. The suggested walk path would consist of several small loops, ensuring that features are seen from different angles. Users should avoid completely linear captures, just walking up and down, and if possible, always approach the end from a different angle. So like you can see, for instance, in the middle image. This, however, doesn't mean that we cannot use our system for roads, tunnels, or power lines, scans and mapping that are linear in nature. It just requires a little bit more planning and making some smaller loops on the way. So in case of Revo or RT system, it's helpful to have a smaller local loops, let's say in every 30 meters in the linear capture, and around 150 meters for Horizon. You would select the group of several trees and loop around them within a diameter of around 10 meters. Suggested capture time for each system is 20 minutes. This way you can process it on the processing computer with which specifications are listed on GeoSLAM website. So something of at least 16 gigabytes of RAM and a good processor. Walking and turns with the system should be smooth. And you might also want to walk a bit slower than your normal walking speed, maybe around 1/3 slower than you would normally walk. This way, you'll just ensure that you'll get a good point density and basically for the features to be recognized. So in this example, you can see that just walking straight, in a straight line up and down, like on the first picture, the point cloud will be created. However, for the best accuracy that you can get from the system, you want to walk in those loops, like in the bigger picture, or in the best case scenario, where if you have tables or chairs, you'll make use of them and make a full loop around. And for instance, if creating floor plans is your applications, this is what you would want to do anyways, to make sure that you cover the room, scan the room, the system fully, and that you don't have any shadows from the furniture if possible. So I will now go into differences between Revo, RT, and Horizon systems and their suitability for different environments. So first system, ZEB Revo. It's got a range of 30 meters. In the brackets, features 15 meters means that you should not be more than 15 meters away from those features. The system also has the highest IP64, which means that it's most suitable for harsh environments like mines where you have dust or more humidity. System can capture up to 43,000 points per second, and resulting point cloud has 1 to 3 centimeters of relative accuracy. The quick guide on the right comes with every system and is also in the user guide. The sequence of the LEDs guides you through the initialization capturing process. It also indicates if the camera is being detected or if you downloaded the data successfully. Just want to highlight here that the recent processing software is Hub 5.3.1 that is also available on geoslam.com website under support. And this hub is licensed with an activation key, not dongles anymore. So in case you haven't upgraded from dongles yet, please email support@geoslam.com with the serial number of the dongle and your Revo system. The second system, Revo RT. System specifications are similar to standard Revo, except the IP, which is 51, as the real-time data logger requires more ventilation. Instead of the light sequence guide, the system has inbuilt Wi-Fi, so the users can use phone or the tablet to connect to the system. And this real-time capability makes it a great tool for property surveys, as data doesn't need to be post-processed, and operators know what they are capturing as they walk. So they can basically do a quick capture and coverage check right at the spot without any waiting. All right, what I wanted to show you is the video of the screen recording during the capture. It's initialization of the system, and as the system starts, you can basically see your trajectory, 9% of the point cloud being captured. But what's important is the indicator on the top right corner, which changes from green, orange to red. And this indicates how good your capture is or how good your SLAM environment is. So looking at the screen, you can actually improve your capture. If you see red indicator, you can walk a bit slower, point the system to more features, and you should see improvement for the light changing to amber or green. Specifications of ZEB Horizon. It's one of the recent systems. The system is collecting 300,000 points per second and has a 100-meter range with features, recommended distance from features being 40 meters maximum. It also makes it a great tool for using outdoors or even using with the UAV. We have a mount for a mattress, DJI mattress 600. IP of the system is 54, which is higher than the RT system, but a little bit lower than standard Revo. I had a question in the previous webinar, what happens if you scan the dust? Unlike Revo or RT, Horizon has intensity. So if you scan some particles in the air, whether it's a dust or light rain or light snow, you will see some air points, but they will have lower intensity than the rest of your capture. So that's something that can be filtered during the post-processing stage. All right, now I will talk a little bit about the capture in different environments that might be more challenging or something to think about depending on the project that you want to capture. So open spaces, that's something that can be captured with any system, but can be a little bit challenging. The SLAM needs features to create accurate trajectories. So in this example, we have a single building here in the open field. It can be captured well, but any system, as long as you start the system facing the building, or let's say the car parked next to it, and then you walk, or in the case of Horizon, fly around it with the system pointing to the building all the time rather than to the empty field. If it, however, happens that the system is not facing any features, this shouldn't be the case for more than 5 seconds. Again, if this is an outdoor capture, something to keep in mind with Horizon, you wouldn't want to be more than 40 meters away from the building. With Revo, you would need to be closer, maximum 15 meters away from the feature. Mapping corridors, and this section applies to corridors of the buildings or even to mapping tunnels. This can be another challenge if corridors or tunnels are straight and narrow without any features or furniture. And you might find that you need to place some artificial features like cardboard boxes, or you can place some equipment of at least 1 meter in size. Alternatively, if you have some rooms that you can access in the corridor, even if this is not what you need to capture, you might want to just open door and do a loop in the room. This way you're not doing purely linear capture. The same applies for capturing tunnels. If you have any openings like this in the bottom of the cross section of the tunnel, on the bottom of the screen, you could make use of them and just make sure that you walk around them, and this way you wouldn't be doing just a linear capture and you would allow to see any possible features in each direction as you turn around. Okay, for capturing with SLAM system, having a features is a must. Something to keep in mind is the nearest features might be behind you, so you might want to point the system so it can see those features all the way as you walk. Any artificial features can be used if they are already not in the environment. Anything within 1 meter in size, recommended would be placing them at 10 meters intervals. And if you are not sure if the environment is good, you can always do a practice scan and process it quickly and to see if you need to bring more features in. 5 seconds is a maximum time that you should be without features if that happens. And just one thing to have in mind is the scan angle of incidence. If there is a feature in the long corridor in front of you, really want to walk towards it to approach it fully, not to just point to it from a great distance of 10 meters or so. If it's on the side, the angle of incidence will mean that there will be less of the point density if you don't walk right through it, and this might not be the best practice to capture those features. So just make sure that you make a walk around them, and any loop around the features will help to create trajectory as well. Tight spaces, this is not really a challenge for the systems, as they are quite compact, flexible. They come with range of accessories like cradles and extension poles, so you can lower them down to manholes or scan the openings in the ceilings. But there is one part, which is really post-processing part, that might be good to mention, and that's a bounding box. So when you hold a scanner and you're doing a handheld capture, there is a default bounding box built around the person that you can see on the right part of the picture. So this way you wouldn't scan yourself over your feet as you're walking. If you're lowering down the system to tight spaces and as soon as you are changing the way you hold the system, the bounding box will change with it as well. And if the space is actually smaller than the bounding box that you are scanning, then it wouldn't actually process any points there. This doesn't mean the points are not captured. All you would need to do in the post-processing stage would be to lower, decrease the bounding box, where you can specify the distance left, right, front, back, top or bottom from the scanner. You can just set it to 0, or if you know your measurements, you can specify them as well. Transitioning between environments, something that you come across probably with every single scan. Just to mention here, if you're moving from one room to another, you either want to walk sideways or backwards, or just simply pause for a second in between the door, moving the system slightly from left and right and allowing it to see the features in one room as well as another. So you actually have the link between the two rooms. If possible, open the door before you do the scan. This way you can transition smoothly, and you will also avoid those opening and closing door ghost points in your point cloud. Same things applies if you are scanning outdoors or you're walking around the building, like on the right picture. If you reach the edge, again, maybe pause for a second. You can sort of paint the building by moving the system slowly up and down, so you allow enough time to see the features on the right and on the left-hand side of the building. If you are capturing with the RT system, it's fairly easy. You can see on the screen what's happening, how good your point cloud is, if you need to slow it down. Capturing with Horizon, it's much more forgiving with the amount of data it's capturing and the range it has to create trajectory, but it's still the best practice if you move slowly from one room to another. Loop closure, important part for SLAM capture with ZEB systems. So in those examples, we have the scenario of A to B points. Say it's a building or a tunnel that needed to be scanned. If the environment allows you and you can walk from A to B in O-shaped trajectory, you're going to reach the best accuracy of the system. So in this case of 1 centimeter measured with Revo. However, this might not often be the case, as in the first picture where you have a U-shaped trajectory. And if you're really just walking from A to B and back the same way, just repeating a linear capture, and your accuracy is not going to be the best that you could get out of the system. So if this is the case of the capture, let's say it's a building, and if you're capturing with Horizon, and you have A and B part of the building, if there are any windows on the site, you could make a use of it because the system's got 100-meter range. So you could, for instance, stick the system out of the window on A part and on B part, and this will help to increase accuracy because it can see the same trees or parked cars outside. But if this is not a possibility, say it's a tunnel, no doors, no windows, then you could alternatively start in the middle and right here between A and B and do sort of a figure of 8 capture where you're doing one loop to A and you're coming again back to the same place, looping back to B and finishing right at the beginning. This way you would have better data accuracy, and we recommend to capture for one capture of 20 minutes. If you can make this figure of 8 in 20 minutes, then great. If the project is longer, you could break it down and do one loop for A and one loop for B, having enough of at least 20 to 30% overlap between the scans, so you can use hub to merge the different scans together. When it comes to multiple floors, building capture, loops can be closed vertically as well as horizontally. So if you have more than one staircase available, make a use of it. You can use one staircase to go up and other staircase to go down and close the loop this way. And of course, as well, capturing in loops in different floors and rooms, in individual floors as well. Again, maybe recommended start would be somewhere in the middle if you're doing more than one capture. So you do one loop, finish the scan, and another loop where you have enough of 20% overlap in between individual scans for merging at the post-processing stage. And what happens if the loop is not closed, or you don't have good enough SLAM environment, or simply capture without the best practices and making any smaller local loops? You can see something similar like on the right, a drift in the data where you can see sort of a building being doubled. And this doesn't mean that the data is completely lost. Hub is not a black box. There are several reprocessing parameters that you could change to improve your data. And also for different environments, just like the bounding box, it's something that you might want to adjust. One good thing about processing is that you could change, let's say, maximum range or use a quick draft mode to check the data on the spot. If you don't have the real-time system, you could do like a first draft processing just to make sure that you covered the entire project that you needed before you leave the site. But also make sure that the data set processed correctly. So I don't want to get into too many details into reprocessing parameters. I will show you the options. But please have a look at GeoSLAM Academy, where you can log in with your system serial number and access all different information. So just to recap, for the best data practice and not allowing any drift in your data, make one loop where you have the same start and finish location facing the same static features. Walk slowly, move the scanner in your hand and do slow turns as well. And make sure that you do a couple of local loops instead of linear capture in Revo system every 30 meters or so, and with Horizon at least every 150 meters. Route planning, important part if you haven't been on the site that you're going to capture, or it might be quite challenging. It's always worth thinking about it, where you're going to have your start and finish location, or how you're going to walk or fly with a system. If it is a capture inside the buildings and the project allows you to do so, if you open the doors, you'll be able to transition more smoothly through the environments and avoid any of those ghost points of the opening doors. You should also identify any challenging areas. They maybe split the capture accordingly. Ensure that you can always close the loop, come back to the same feature where you started. And if your capture is more than 20 minutes, it's fine. You can merge the data afterwards. Just ensure that you have 20% overlap between them. This overlapped part also needs to have features, common features in there. If you are using ZEBCam, something that I will talk about just a little bit later, but it's another factor to have in mind, that if you want to colorize the data or capture the full video, that you adjust the capture, so capture the entire project within the field of view of the camera as well. Breaking down scans. One of the older examples from Mumbai, when the project required a scan of 1.25 hectares of the site. This was an outdoor scan with Revo, and on the bottom left picture you actually see individual scans broken by different colors. You can see overlap between them. This would be, for bigger projects, a suggested option how to break down the scans, but you don't just capture the linear roads and then individual smaller streets, but rather break it in a way that they allow you to make this loop where you can approach the start location from a different walk path that you started originally. And just to mention again the processing options a little bit, I mentioned before HAP 5.3.1, that is the latest release available for the download. What it also allows you to do is to change your processing settings before you drag and drop the data to be processed. So if you know that you're capturing tight spaces and they are quite narrow and the default bounding box around the person is not the best one to be used, something that you can change in your configuration, advanced options. And as a result, once the settings are changed on the drop-down menu, you will see that the default processing options are being overridden. More information is available on Academy. But if you need to change the processing either for the tunnel environment or for the UAV capture, we would be always starting with changing the local parameters first, which is SLAM. It's based on every second of the capture. And global part of the SLAM is computed when you finish at the same location where you started, and the error is evenly distributed throughout the capture. If you have more questions on the processing parameters, I can also get back to them during the questions and answers at the end. Right, capturing with different cameras, starting with ZEBCam. We also have available ZEBPano and Discovery. Just to highlight the differences between Revo and Horizon. With the Revo or RT, ZEBCam needs to be charged separately, needs to be powered on and off in the correct sequence. So you start a scan first, then you need to start the camera, and you sort of do it in the mirrored way at the end. Camera also requires a micro USB to be plugged into the system during the capture. Data is collected locally on micro SD card. It comes with 32 gigabytes of storage, can be increased. And in case of Revo system and Horizon system as well, the system LED will pulse red twice per second, which indicates that the camera has been detected. With Horizon, as that's one of the newer systems, we integrated the cable connections, and the camera also charges from the system and starts recording automatically as the scanner starts recording as well. Storage and recording is done on micro SD card, just the same as with Revo RT system. But the recording display is also open, so it allows you to see if the recording is working correctly, but also the field of view of the camera, how much it captures. So the scanner's field of view is 360 degrees times 270 degrees, while camera has a wide field of view of 170 degrees horizontally. Vertically, it's much less than that. So you might want to, if you're capturing the buildings, you might sort of want to paint the building up and down to make sure that the entire structure is in your field of view of the camera as well, not just at the edges, because the edges are distorted with such wide range of field of view. Those distorted parts are not used for colorization. Same if you're capturing inside of the buildings and you want to capture the video of the room, make sure that you get it from the corner or from the door and sort of slowly paint the entire room, that you can capture the features or the room from a greater distance on the camera because of its field of view. So it's possible to colorize the data with ZEBCam, but it's mostly used for contextual information. It's recording MP4 video, just give you more insights into what was happening on the site. Some people like to turn the audio on and just walk through the capture and also use that as a reference. When it comes to colorization, this is integrated within Hub. You need to download the video data, and within Hub you can just click on add video, and the colorization is happening in the background while the Hub is still open. ZEBPano is another add-on option. It's quite recent, works with Revo, RT, and Horizon. And it's capturing 360 images that are very valuable, for instance, for property surveys. And it's again a great contextual panoramic reference. It's based, works as a stop and go capture. There is an external trigger that if you're walking in the room and in the middle of it, you want to get 360 image, you would just stop, pause, and press the trigger to take a picture. You don't need to stop for a specific number of seconds, but you need to be still for the images to be aligned along the point cloud or its trajectory. It's also, the workflow is integrated with Draw. So if you use the ZEBPano option, the same Hub license will license this Pano add-on, and you're then able to get your data directly into Draw, see your image positions, and open the images and see the detail of the room that you wouldn't see from the point cloud. This camera is, however, not used for colorization or for measurements from the images. ZEB Discovery, the most recent system, however, can do more than that. It's used as a backpack, between Horizon and the camera. There is a bore side calibration. The camera is capturing data continuously up to 7 frames per second. So we are able to measure both from the images and from the point cloud, and colorization is also giving us pretty neat results, and is also done in the post-processing step in Orbit software that we partnered with to be able to view the data and also do different vectorization and asset management workflows. Just to show you a little bit more about the recent Discovery colorization. This is your application or requirement. Discovery is definitely the best one for the colorized results. And this is a Roosevelt Memorial in DC that was captured a few weeks ago. Just one thing to have in mind with Discovery is that the Horizon is mounted at the back, and you're not all of a sudden able to paint the buildings as you would be used to when you are just doing the handheld capture, and to be able to capture the top structures of the buildings. One needs to keep a distance from them to be able to have a good scan angle to reach the top parts. Getting into UAV applications with Horizon. Because of Horizon range and number of points that it captures, we also tested it up to 10 meters per second in the air from the DJI matrix and up to 30 miles per hour from the car. A couple of key points for the UAV applications that are similar to handheld capture. You also need to identify takeoff and landing area which has enough features, but you probably don't want to be too close to the building, so a parked car or the UAV box might be a good feature to use. You can use different flight planning software for the area to capture the data and just make sure that you have enough overlap between the flight lines. Processing on site always recommended that you check the data quality and coverage density, something that only Horizon has and not Revo or RT system. Gives more information about the structure and the environment, and also can be used for the georeferencing. Use the reflective targets like checkerboards or the white paint marks on the roads. Merging of the UAV data can be done the same in hub if you have enough of at least 20 to 30% overlap between the flights. And the ZEBCam on the Horizon can be used for the flight as well. Just to explain a little bit more, if you're using automated mission planning software where you can add waypoints, it's easier way to control your constant speed and altitude and point density, or even the camera footage and overlap for doing the data colorization at the end. But one thing is recommended that if you set the waypoints, set a curve setting around them, so you just don't fly, say, 5 meters per second and suddenly stop to do a 90-degree turn to follow another waypoint. In general, the recommended speed or height does depend on the project. One thing to have in mind is that you shouldn't be more than 40 meters away from the features, and something smooth like 5 meters per second or less than that for the flight speed, and maybe up to 50 meters flying height. You can use that to create your flight patterns. Another options for the manual flights, if you have a smaller project, might be easier. You have also more flexibility or control over making the turns smooth. And this way, it can be also more efficient for the batteries, but might not be ideal for larger projects. And similarly, like capturing multiple floors, if you have a single object, a single house or a pylon, you might be able to close the loop vertically as well by flying around it. So all those points that you see in the air, just wanted to point them out as I kept them here on purpose. They are points that are scanned, part of the scanned propeller on the UAV. This is again something that you might want to change by changing the bounding box during the processing settings, as the Horizon is also pitched 20 degrees, which is better for the weight distribution if you're doing a handheld capture. But if you have the system mounted in the vehicle, on the UAV, bounding box can get rid of all those close points from the given objects. UAV and handheld data, any Revo data can be actually quite nicely combined. If you are flying above the building and then capturing inside, always make sure that you have enough overlap. So if you're flying, for instance, and then doing indoor capture, start outdoors, make a small loop so you have 20% of overlap there, and then move into inside capture. And you can use hub to merge this data. Georeferencing is a part of post-processing. There are different ways how you can use targets and georeference data at the end, as long as you have a good distribution of your targets throughout the project. For instance, spheres, they can be used both with Horizon, Revo, and RT system. For the best results, you should make sure that you scan the entire diameter. So walk around them and point the system to the sphere. Coarse Horizon has intensity. You could use checkerboard patterns or any reflective material that reflects well in near-infrared electromagnetic spectrum. And you will be able to see those points by intensity in the viewer, or actually use draw as the workflow to do the data transformation and export a georeference result. So using the checkerboards, again, for the best results, walking with Horizon, because the Horizon is pitched by 20 degrees as you're walking, make sure that you point the system down and walk a little bit slower around it, so you get a good point density on your targets. And for the UAV in general, we recommend maybe 0.5 meters in size of the targets for flying height of 15 to 20 meters. Again, the new option for Horizon from HAP 5.3.1 is the use of reference plate. So for those who have Revo, you would have been able to use reference plate for some time, but HAP 5.3.1 now applies offsets automatically for both Horizon and Revo data, which means that if you have control points like surveying nails or targets that you cannot see in the point cloud, so even if it's high intensity and you have Revo system, you might be able to place a reference plate over the checkerboard, or with Horizon if it's anything smaller to be picked in the point cloud. Reference plate is slightly different between the Revo and Horizon. Horizon has a slightly longer one, and just to collect those data automatically, place the system static above the control point, leave it static for 5 seconds minimum, and this control point will be automatically recorded in your data as you do the processing. So within HAP 5.3.1, you have an option to export those reference points, which will have XYZ location, the time and duration of the capture, then bring it into draw and do georeferencing without looking for where those points or checkerboard targets have been placed. With Horizon, you can also use the reference plates on the walls. This is only possible with Horizon. So with Revo or RT system, you can only place the system on the floor to collect those points automatically. With Horizon, you can do both floors or walls as long as you keep it for 5 seconds. But also, you should be careful how you turn the system. So if you're collecting a point on the wall with Horizon, make sure that you don't shadow it with your body for 5 seconds, and you turn it in a way so it can see some features. Same applies if you're capturing outdoors. 5 seconds is the maximum period that the system should be without features, so you're better off placing it, seeing a parked car or a house rather than the moving traffic or moving crowd of people. All right, so thank you very much. I hope this has been helpful to you. I will now have a look at the questions and try to answer as many as I can. For more materials, have a look at GeoSLAM Academy. These webinars, among others, they are uploaded there with more processing materials when it comes to HAP, draw, or different systems. So that can be a useful material for you. And then if you have any follow-up questions, drop an email to info@geoslam.com, where we can answer you maybe more. Right, so I'll give you just a few minutes. If there are any questions, I'll answer them now. Question from Peter: is georeferencing possible in HAB spheres or needs to be done in other software? It is a good question. At the moment, the workflow is that you would bring, whether are those spheres or targets, you would bring those points into draw. So draw is part of GeoSLAM HAB, and with every ZEB system, draw start comes as a package with it. There are different draw modules, then depending if you are in the mining environment, if you are creating BIM models, you can use draw BIM with the plugins for Revit, or having draw plan, which will allow you to do or have more floor plan options. And so that's fairly easy. Into draw, you can open the data, you have an option to specify diameter of the sphere, place it in top view. So if you haven't used draw before, it's projecting the point cloud into 2D views, top view, side views from where you can do the cross sections. And with mobile mapping systems and structured point cloud data, you need to place those spheres manually. But something that we are working on would be more automated georeferencing included in the hub directly. And this wouldn't be done with spheres, but this would be done with a reference plate, with reference points that are automatically recorded while being static for 5 seconds. Is there sphere detection or any automatic process? Within draw, you can see the sphere tool, and it allows you to run the automated sphere detection, but only on the structured point clouds at the moment. So if you have, or if you're using any static scanners as well for the projects, structured point clouds will allow you to run automatic search, and for the mobile data, you would need to place those spheres manually. Again, this is different for the reference points, as they are automatically recorded. You can easily just bring those points into draw and then match them with your measured ground control points, GPS coordinates. In Academy page, there is also draw webinar that covers georeferencing and individual processes with placing spheres or using checkerboard targets and running step-by-step and how to do the transform calculation and export the georeference point cloud. So please have a look there. And if you have more questions, please email to info@geoslam.com. Thank you very much for today and have a good day all. Thank you. Bye-bye.